Okay, so we are starting topic one. Topic one is introduction. So today we're focusing on arithmetic and geometric progression. Okay, so our objective here today is first objective is to identify arithmetic and geometric sequence. And then at the end of this lesson, you should be able to calculate the terms in arithmetic and geometric sequence, calculate the sum of terms in arithmetic and geometric sequence, and to calculate the sum to infinity of a geometric progression. So at the end of this lesson today, you must be able to do all these four things. Hopefully we'll be able to do this. Okay, so let's start with the terms first. Okay, these are some of the terms that you need to understand in order to follow this topic. Okay, so the first term is sequence. What is meant by sequence? I'll give you an example of a sequence like this. Okay, T1, T2, T3, T4, say T5. Okay, this is a sequence. T refers to terms. T refers to terms. So in this sequence, we have term 1, term 2, term 3, term 4, and term 5. Okay, a sequence is a succession, okay, or a list of terms arranged according to a rule. So these terms here they are arranged according to a rule. For example, we have a sequence like this: 2, 4, 6, 8, 10. Okay, so this sequence here is arranged to a rule. What rule is this? What rule are they using here? Anyone? How do you get from 2 to 4?
+2.
+2.
Yeah, so that is the rule, +2. Okay, so the rule is +2. How many terms are there in this sequence?
5.
Sequence 1, yes. Sequence 1 has only 5 terms. Okay, so if I extend this sequence like this, if I put another 3 dots, it means that the sequence is extending. And if I put an N at the back, how many terms does this sequence have now?
N term.
Yes, n terms. So now the sequence has n terms. Okay, so this is what we mean by sequence. Okay, a series is the sum of the terms of a sequence. That means a series will be T1 plus T2 plus T3 plus T4 plus T5. Okay, a series is the sum of the terms of a sequence. When we have this addition sign, then we call it a series. We don't call it a sequence anymore. Okay, sum refers to the total number of the total when you add all the terms. So the sum actually is T1 plus T2 plus T3 plus T4 plus T5 equals to how much? Okay, this is the sum. Okay, so sometimes we use a notation like this. Okay, what do we call this? This symbol, what do we call this symbol? I'm sure you've seen this before.
Total of.
Total of. Okay, but there's a name. It means total of. It means the sum. But there's a name for the symbol. The name is sigma. Sigma. This is called sigma. Okay, S-I-G-M-A. Sigma. So if we say sigma n equals to 1 and up here we write 6, say we write here 4n plus 1. Okay, it means that the sum of the terms in the sequence 4n plus 1 with n going from 1 to 6, that is how we read this. Okay, the sum of terms in 4n plus 1 with n going from 1 to 6. Okay, so for this notation here, what is the first term? What is the first term here? If you are given this. Anybody? Okay, tell me how many terms are there from this notation here. Tell me how many terms are there?
Six.
Six.
Yes, 6. Because n is 1 to 6. So what is the first term?
One.
Six.
N is equals to 1. When n is 1,
Five. Six.
5. Yes, 5. Huh? 4 times 1 is
Okay.
4. 4 plus 1 is 5. When n is 2,
But
3.
15.
4, 17. Huh? 5 will be 21 and 6 will be 25. Okay, these are the terms. Okay, but we can summarize it and write it like this. Sigma n is 1 going to 6, 4n plus 1. 4n plus 1 is the formula for the sequence. Okay, or we can also sometimes they write it like this. Sigma n is equals to 1 to infinity. What does this mean? How many terms are there?
Infinity.
Yes, infinity. There is no end. The sequence doesn't stop. It's going on and on. Okay, so there are infinity terms. The nth term can be defined by this formula. Okay, that's what this symbol means, because sometimes you might see that. Okay, okay. Next term that we're going to look at is finite series. A series is finite if it stops after a finite number of terms. Okay, like what we did earlier, 2, 4, 6, 8. So there are 4 terms in this series. So therefore, this series is finite because it stops after 4 terms. So any series that stops after a certain number of terms is known as finite series. Okay, so infinite series are series if it continues indefinitely. If the same series, if you write like this, okay, and then you put 1, 2, 3 dots here. Usually we only write 3 dots. 3 dots means it's continuing. Okay, if this series is written like this, it means that it continues indefinitely, and this series is known as infinite series. Okay, so these are the terms that we have to know before we continue with this chapter. Okay, so moving on. Okay, so we're going to look at arithmetic sequence first. We're going to start with arithmetic sequence. Supposing you have a sequence like this. Okay, supposing you have T1, T2, T3, T4, and Tn. Okay, you have a series with so many terms. Okay, so in an arithmetic progression, T2 minus T1 is known as D, or the common difference. Okay, so T3 minus T2 will be D also. Okay, T4 minus T3 is D. The difference is the same. The common difference here is the same. This minus this is D. T4 minus T3 is D. So the common difference is D. Okay. So if you have a sequence like this, the next term will be, because the common difference is D. If the first term is A, the second term will be A plus D. Then we have A plus 2D, A plus 3D. All right. If the first term is A, the second term will be A plus D, because the common difference is D. The third term will be A plus D plus D. So it becomes A plus 2D. The fourth term is A plus 2D plus D. So it becomes A plus 3D. Okay. So that means term 1 is A. This can also be written as A plus 1 minus 1D, correct? 1 minus 1 is 0. 0 times D is 0. So it is A. Term 2, which is A plus D, can also be written as A plus 2 minus 1D. Term 3, A plus 2D, can be written as A plus 3 minus 1D. Term 4 is A plus 3D, can be written as A plus 4 minus 1D. Okay. Term 4, 4 minus 1. Term 3, 3 minus 1. Term 2, 2 minus 1. So how about term n? How do we write term n?
2 plus n minus 1d.
Yes, a plus n minus 1 d. Okay, so this is our formula for term n. Okay, where a is the first term. A always refers to the first term. N is the number of terms. Okay, so if you have 8, then n is 8 lah. D is the common difference. Okay, and Tn is the nth term. Okay, so this is how we find the nth term using this formula. Okay, using this formula we can find the nth term for an arithmetic progression. Okay, you look at the arithmetic sequence shown above: 3, 6, 9, 12, 15. What is the D here for the first sequence? What is D? D is the common difference. 3. How do you find that?
6 minus 3.
Yes, term 2 minus term 1, okay? 6 minus 3 is equals to 3. Then you must check whether term 3 minus term 2 is the same. If it's all the same, it is an arithmetic sequence. So in this case, everything is the same. This is an arithmetic sequence. Okay, number 2, is it an arithmetic sequence? How do you know? Find D. What is the D for number 2?
Negative 2.
Correct, D is negative 2. Is it the same for everything?
Yes.
Yes, so it is a arithmetic sequence. How about number 3?
Negative 5.
Is it the same for everything?
Yes, madam.
Okay, so it's negative 5. So this is the sequence. How about number 4? What is the first one? 7 over 2 minus 1 over 2 is equals to? 6 over 2 is 3. The second
3.
term, 11 over 2 minus 7 over 2 is equals to? 4
2.
over 2 is 2. Is it the same? It's not.
No.
So this is not the same. Therefore, this one is not an arithmetic sequence. Okay, so this is for arithmetic sequence, the terms. So now we're going to look at the sum of the arithmetic sequence. Okay. Okay, now we're going to look at the sum. Okay, sum of the first n terms. Okay. Okay. For some of the first n terms, we use the notation Sn. Sn means sum of the first n terms. So we had our sequence A plus D, A plus 2D, A plus 3D, and so on. Okay. The last term was A plus n minus 1D. Okay. So the sum of this sequence is sum, right? So A plus D plus A plus 2D plus so on until we have A plus n minus 1D. Correct? What is the term before this? Before A plus n minus 1D, what is the term? What is here? A plus anyone?
1 minus 1.
N minus 1. So we want to minus what? We want to minus 1. N minus 2D. Okay. If it's n minus 1, the one before it is always n minus 2. Okay. So it's n a plus n minus 2d, the term before it. Okay. So, and this is, say, this is equation 1. Okay. Equation 1. So equation 2, we rewrite the same thing. We rewrite the same sequence. Only thing, we write the last one first. We write the last term first. Okay. So this is a plus n minus 1d. A plus n minus 1d plus a plus n minus 2d plus a plus 2d plus a plus d plus a. Okay, it's the same thing, just that we have rewritten it. Last term first, first term last. Okay, so now we have two different equations. Now we are going to add both equations, equation 1 plus equation 2. So Sn plus Sn is 2Sn. Okay, so now when we add everything, what do we get? You see, when we add these two,
2A.
this and this we're
Times
going to add. This and this we're going to add. Okay, and the last one is this one we're going to add. These two we're going to add. So when we add all this, what do we get here? So these two, when we add these first two, we get
2A.
yes 2a plus n minus 1 d.
D.
Second two, when we add, also we get 2a plus n minus 1 d. Okay. After that, when we add these two, also the second last two, we also get 2a plus n minus 1 d. The last two also 2a plus n minus 1 d. Okay, so the term until n terms lah. Okay, so therefore 2Sn, we have n terms, right? Is also equals to n times by 2a plus n minus 1 d. How many 2a plus n minus 1 d? N. So we multiply it by n. From here, we know that Sn is equals to n over 2 into 2a plus n minus 1 d. Okay, so this is our formula for the sum of n terms. Okay, but if we know our first term and we know our last term, there is another formula that we can use. Okay, Sn is equals to a. Sn is equals to n over 2a plus l. Okay, where a is first term and l is last term. So you can use either of the formula to find the sum of terms. Okay? Can? So the only two formulas that you must remember. You don't even have to remember. You just know which formula to use. Okay, let's look at one example. Okay, example of an arithmetic sequence. Okay, example 1a, given the arithmetic sequence 2, 10, 18. Okay, so you're given 2, 10, 18, and so on. Find the 10th term. So what are you finding here? 10th term is?
T10.
Yes, we want to find 10th term. Okay, so what do we need to know to find the 10th term? What is the formula for the 10th term?
Tn.
Tn is equal to
A plus
E plus
a
n
plus
minus
n
1.
minus 1d, correct?
D.
So what do we need to know here? So do we know what is a? What is a?
2.
2. What is our d?
8.
10 minus 2, d is 10 minus 2 is 8, yes. What is n? N is the number of terms. How many terms?
10.
10, correct. So put into our formula. So Tn is T10 is equals to 2 plus 10 minus 1 and D is 8. How much is this? 10 minus 1? 9. 9 times 8? 72.
2.
72 plus 2?
74.
74. So T10 is 74. That's number 1. Okay. Okay. So number 2. Part 2. Find the sum of the first 10 terms. So what are we finding here? Sum of the first 10 terms. S
N.
Sn.
Sn. So what formula are we going to use? Let's look at the formula. Sn is n over 2 into 2a
2,
plus
2A
n
plus
minus 1 d. So we know everything, right? Okay. So
Yes.
S10 is equals to n is 10
10
over
over
2.
2.
A is 2
2.
plus
10.
10.
minus 1 times 8. Okay, solve this. What do we get?
A is 2
Oh, this is 9
plus
items.
10
8
times
72 plus 4, 76 times 5. So it is 380, correct?
Yes.
Yes. Okay. But there's also, let's try the other formula. We also can use this formula as n is n over 2a plus l, because we know the last term, because they said find the sum of the first 10 terms. We already found the 10th term in part 1. We know the 10th term. So we know the last term. So we can use this formula. So as 10 is equals to 10 over 2. First term is 2, last term is 74. Okay, gives us 380, same thing. Okay, so you can, if you know the last term, you can use this formula. It's much easier. If you don't know the last term, use the first formula. Okay, so that is for part A. Okay, now let's look at part B. Okay, given the arithmetic sequence, part B, given the arithmetic sequence 30, 23, 16, 19, 2, find the 12th term and the sum of the first 12 terms. Okay, find T12. How do you find T12? First, let's find what is A, D, N. Okay, A is 30, correct? D
Yeah.
is, how much is D?
12.
Negative.
negative 7.
Yes, negative 7. N is, find the 12th term. So N is
12.
12, yeah. So put into your formula,
Right.
T12 is, A is 30 plus N is 12 minus 1, D is negative 7. So what do we get here?
Negative 47.
Yes, good, negative 47, okay? And then part 2 is the sum of the first 12 terms, as N. Which formula are we going to use? Let's try the second formula, very simple, right? Second formula. So as N means we're using as 12, huh? So S12 is equals to N over 2. N is 12 over 2. A first term we know is 30. Last term we know is negative 47. Okay?
47.
Okay, so what's our answer? Negative 102. Okay, that's our answer. Okay, okay, so far okay? Arithmetic sequence.
So far, okay, madam.
Okay, yeah? Okay. So now we move on to geometric progression. Okay. Okay, for geometric progression, say you are given this series, AR, AR square, AR cube, and so on. Okay. So here, the first term T1 is A, right? First term is A. A can also be written as A R to the power of 0, because R to the power of 0 is 1. So 1 times A is A. Okay. So term 2 is AR. AR can be written as AR 2 minus 1. 2 minus 1 is 1. So it's AR. Term 3 can be written as AR square, which is AR 3 minus 1. 3 minus 1 is 2. Therefore, term N is AR from here 3, 3 minus 1, 2, 2 minus 1. So term n will be AR,
And minus
n minus 1, yes. So this is the formula for Tn AR n minus 1, where n is the number of terms, okay? N is the number of terms, and R is the common ratio, not difference. Just now for arithmetic progression is common difference. Here R is the common difference, okay? Okay, let's look at the first series here. First one here, number 1 here, okay? 1, 3, 9, 27, 81. What is the R here? So R is equals to 9 term 2, okay? Term 2 divided by term 1, which is 9 over 3 is equals to 3, or it is term 3 divided by term 2 is 27 divided by 9 is equals to 3. So the common ratio R is 3, it's all the same, so this is a geometric sequence. Okay, for number 2, R is 10 divided by negative 5 is negative 2, or negative 20 divided by 10 also negative 2, or 40 divided by negative 20 negative 2. So R here is negative 2. So common ratio is negative 2. Okay. So number 3, what is R? You tell me, what is R? 3 over 2 divided by 1 over 4 is times 4 over 1. So R is 6, correct?
6. Yes.
Okay, so this is for geometric ratio, this is the sequence, and this is the R. Okay, so now we want to look at the terms for geometric sequence. So we already know how to find the term for geometric sequence. Now we're going to look at the sum of terms for geometric sequence. Okay, so a sum of terms for geometric sequence. Also we use the term as n. Okay, so our sequence is AR, AR square, AR cube, and so on. Okay, so sum of terms Sn is equals to A plus AR plus AR squared plus AR cube, and so on until the last will be ARn minus 1. Okay, this is equation 1. Equation 2 is we times equation 1 with R. Multiplied equation 1 with R, Rsn. So we have AR plus AR squared plus AR cubed plus AR to the power of 4 until the end here is, when we multiply this by R, what do we get? AR to the power of n. Okay, correct?
yes.
This is actually ARn times R to the power of negative 1, right? Times another R. So we get ARn. Okay, so we have two equations now. Now equation 1 minus equation 2. Okay, equation 1 minus equation 2. So we have Sn minus Rsn is equals to, we minus this. When we minus, what do we get? Let's see. When we minus, these two cancels off, right? These two cancels off. These two cancels off until we are left with, these two will also cancel off. What are we left with? We are left with A minus AR to the power of n. This is what happens when we cancel everything, okay? So when we factorize this, we have Sn into 1 minus R is equals to A into 1 minus R to the power of n. So Sn is equals to A times 1 minus Rn over 1 minus R. Okay, this is the formula for Sn. But this formula is only where modulus R is equals to 1. That means R is more than negative 1 but less than 1. Only in this condition we use this formula. Where R, modulus R sorry, this is less than 1. Where modulus r is greater than 1, that means r is greater than 1 or r is less than -1, the formula is reversed. It is a rn minus 1 over r minus 1. Okay, so for the sum of geometric progressions, there is two formulas to use. You can choose either one. When the ratio is between -1 and 1, then you use the first formula. When your ratio is more than 1, that means when this is 0, 1, -1. When your ratio is within here, you use the first formula. When your ratio is outside here, it doesn't matter negative or positive, you use the second formula. Okay? Okay, now let's look at some examples. Okay, example 2. Given the following geometric sequence, okay, we're given 5, 15, 45, 135. Find A, the 8th term and the 10th term. So what do we want to find here? T, 8 and T, 10. So what is the formula for T, for geometric progression? Tn is equals to
A plus
A,
plus
A plus Tn is AR n to the power of n minus 1. So what is our A here?
5.
5. R,
15 over 5.
how much is that? 3.
3.
N
and
is
is 8
8.
8,
and
yes.
10.
So put into the formula, T8 is equals to 5, R is 3 to the power of n minus 1. So this is 5, actually times 3 to the power of 7. So what do we get? 5 to the power of, so we get, this is quite a big number. So this is 10,935. Okay, correct? So this is our
Yes.
answer. Okay, and then we have one more, T10. T10, same thing. So T10 is 5 times R is 3, 10 minus 1. Okay, so T10 will be 28,415. Okay, that's for part A. Okay. Now part B, the sum of the first 8 terms. We want to find the sum of the first 8 terms. Which formula are we going to use? Which formula are we going to use? Are we going to use Rn minus 1 or 1 minus Rn?
Rn minus 1.
Why?
Great.
Over than 1.
Yes,
More than
1. So we're using this formula. So we want to find the sum of the first 8 terms. So S8 is equals to, our A is 5, R is 3, N is 8. N is 8 minus 1 over R is 3 minus 1. Okay. So when we solve this, you can use a calculator and do this. So you solve this, you get 16,400. Okay, that's it, finished. Okay, so we just have to identify the terms, identify the first term, identify the common ratio, the number of terms, put into the formula, that's all. Okay, so this is for geometric progression. Okay, so we got one more thing to learn. That is okay, our last subtopic here is infinite geometric progression. Okay, infinite geometric progression. So this is our series, A plus AR. We're only going to look at the sum, okay? Plus, this is the last term, okay? So we know this. So in this case, okay, in this case, we know that Sn is equals to A 1 minus Rn over 1 minus R. Okay, where modulus R is less than 1. That means R is less than negative 1 and 1. So we know this formula already. Okay, so when we look at this formula, Sn gets larger. Okay, and as n gets bigger and bigger, that means the sequence is growing longer and longer. What happens to our Rn? If we are using this formula where R is between negative 1 and 1, as our n gets bigger and bigger, as this n goes bigger, become 8, 10, 12, 14, 21, 300 and so on, okay? What happens to the value of Rn? Does it get bigger or does it become smaller?
Bigger.
Why bigger? Okay, but you must take this into consideration. Our R is in between 1 and negative 1. That means give me a sample value for R. If R is between these two values, what is the possible value for R? Anything?
0.5.
Yes, 0.5. 0.5 is what? Half, isn't it? 0.5 is half. So if half to the power of 2, what is half to the power of 2? Half times half, right? Is 1 over 4. What is half to the power of 4? 1 over 2 times 1 over 2 times 1 over 2 times 1 over 2 is 2 times 2, 4, 4 times 2, 8, 8 times 16. 1 over 16. So what happens when this number becomes bigger and bigger and bigger? What happens to this value here? It becomes smaller, yes, because the R is between negative 1 and 1. It is always a proper fraction. Okay, it's always a proper fraction. That's why as n gets larger and larger, Rn gets
Smaller.
smaller and smaller. Okay, Rn gets smaller and smaller. Therefore, if the series is infinite, infinite means there is no end to the series. The n is getting bigger and bigger. Okay, so for infinite series, as n approaches, sorry, before that I want to write something else. That means from here we know that as n approaches infinity, that means n is getting bigger and bigger and bigger. Rn approaches, Rn is becoming smaller and smaller and smaller, so it approaches 0. Okay, so as n approaches infinity, Rn approaches 0. This is what we know from there. Okay, so therefore for infinite series, not infinite, infinite series, as n approaches a 1 minus Rn approaches 0 over 1 minus R. This gives us a over 1 minus R. Okay, therefore Sn is equals to a over 1 minus R, where modulus R is less than 1. So when modulus R is less than 1, this is the formula that we use to find the sum. That means if our series doesn't stop, it goes on and on and on, and they ask you to find the sum of the terms, we use this formula Sn is equals to a over 1 minus R. Okay, only for this situation. The other situation we cannot calculate where R is more than 1. Okay, Cam? Okay, let's look at some examples. Okay, example 3. Find the nth term of a geometric progression given this. Okay, it's given that the nth term of a geometric progression is this. This is actually 81 times negative 1 over 3 to the power of n. Okay, so they ask you to find the sum to infinity. They ask you to find the sum to infinity. So which formula must we use? We have to use the formula Sn is equals to
1 minus 1 over,
yes, 1 over R, correct? Okay, so before this, we need to find. Do we know our A and R from here, from the question? Do we know A and R?
No.
We don't know. So we have to find. How do we find? It's given the nth term. That means this is Tn. Tn is given. How do we find the first term?
Put 1, right?
Yes. So the first term is n is 1. So substitute n for 1. So 81 into negative 1 over 3 to the power of 1. How much is this? Negative 27. So therefore we know that A is negative 27. Now we need to find R. How do we find R? What do we need to find first?
Divide. Searching
Yes, we
for
did
terms
divide.
2.
But before that,
Right.
we have to find?
Terms 2.
T2.
Yes, correct. Term 2. Term 2 is 81 times negative 103 to the power of 2. Okay, so this will give us, this is times 1 over 9. So this will give us 9. Okay, term 2 is 9. So from here, we can find R. R is term 2 divided by term 1 is equals to 9 over negative 27. This is negative 1 over 3. Okay, so our R is negative 1 over 3. A is negative 27. Put into the formula, Sn is equals to negative 27 divided by 1 minus negative 1 over 3. Yeah? So this is actually negative 27 over 1 is 3 over 3. Yeah? Negative and negative positive. 3 over 3 plus 1 over 3 is 4 over 3. Okay, solve this and you get negative 21 over 4. Okay, so that is how we do solve problems related to infinity. Okay, can write. Okay, last example. Okay, for this example, write the recurring decimal. Okay, it's like this here. There's a dash up here. So you know that what does this dash mean above 5? What does it mean? You learned it last semester.
0.45454545.
Yes, not 4 5. It's 0.4555. The dash is only above 4. Okay. Oh,
Oh,
sorry, only above 5. So it's
okay.
actually 0.45. Only the 5 is repeating. Okay. 4 is not repeating. So write the recurring decimal 0.45 as the sum of a geometric progression. So we know that, yeah, 0.45 is actually equals to 0.4 plus 0.05 plus 0.005 plus 0.0005 and so on, correct? This is what it means right up here. This is what it means. So this also equals to 0.4 plus 5 over 100 plus 5 over 1000 plus 5 over 10,000 and so on. Okay? And so on. So this is a geometric progression already. If we want to prove it, okay, this part is already geometric progression. If we want to prove it, we can find the R. What is the R in this case? R is 5 over 1000 divided by 5 over 100. This is 5 over 1000 divided by 5 over 100 is times 100 over 5. So R is 1 over 10. Okay, if you check the whole thing, you will find R is 10. So the ratio, we have a common ratio here. So we have already written it as a sum of geometric progression. Okay. Okay, now part B. Yeah. So, sorry. So part B. Part B. Yeah. Use your answer to part A to show that 0.45 can be written as 41 over 95. Okay. So we know that we can use the formula for sum. So we know this is 0.4 and at the back here, we need to find the sum for this. Okay, what formula will we use to find for the sum for part B? we know this A is 0.4. We need to find the sum for part B. What formula are we going to use for part B? What kind of series is this? Finite or infinite?
Infinite.
Infinite, correct. So infinite, what formula are we going to use? Sn is equals to
Sn A
A
over
over 1
1
minus R. Okay, so let's find the sum of all this. What is A? First term is?
0.4.
No, we're only going to find the sum for this
0.05.
part only, okay? From 5
Okay.
over 100 until infinity. So this is our first term, okay? So A is 5 over 100. Okay, over 1 minus, what is R?
0.1, 1 over
1
10.
over 10, or 0.1, correct? So this
Yes.
is 5 over 100 times 1 is 10 over 10. 10 over 10 minus 1 over 10 is 9 over 10. Divide by 9 over 10 is 10 times 10 over 9, okay? So we get 5 over 90, sorry, 5 over 90 already. Now if we add everything together, okay, 0.45. If we add this, the sum of 0.45 is actually 0.4 plus 5 over 90, because 5 over 90 is from 5 over 100 until infinity. Okay, so 0.45 is this plus this is 4 over 10 plus 5 over 90 is actually 4 over 10 is times 9 will be 36 over 90 plus 5 over 90 is 41 over 90. Okay. Okay. So this is how we